This experiment is a demonstration of frustrated total internal reflection in microwaves. To the left here we have a microwave emitter which is sending a beam of microwaves into this prism, which is made up of polystyrene pellets inside a cardboard container. On this side over here we have a microwave detector. Now, because of the angle here, we're going to have total internal reflection at this interface, and that means in geometrical optics that outside here in the air, which is next to this cardboard surface, there should be no microwaves coming through. However, in physical optics we know that in fact there will be some part of a signal which will die out exponentially as I move away from that surface. We're going to use the diode to try to find that signal. The diode is connected to an amplifier here, and the amplifier then goes to a lock-in amplifier and an oscilloscope. Meanwhile, we're turning the emitter on and off using this modulator here at 3,000 times per second. What you see on the oscilloscope screen are two signals. One of them, the very clear, sharp sawtooth, is our turning on the emitter 3,000 times per second. The noisy sawtooth-like signal that you see behind that, that is the signal coming from our detector. I'm going to pull the detector away from that cardboard surface and watch what happens to that noisy signal. It disappears, and it disappears by taking the diode a fraction of an inch away from the surface. I've now returned it to where it was next to the cardboard surface, and there it is. I can also look at this effect on the lock-in amplifier, as the number here, both the needle and the number, decrease as I pull the detector away from the cardboard surface, as I'm doing right now. We see that the signal goes to 0, and as I return the diode to that surface, it goes back to its earlier value. Again, what I'm doing here is pulling the diode away from the surface, and as I do it I see that there is still a signal of microwaves coming through, but that signal dies off exponentially. This is called an evanescent wave.